All right, let's go ahead and get started. Turn your textbooks to page 450, page 450, and you did page 450, 451, numbers 25 through 29, number 33, and number 34. We are looking at a quiz coming up later on this hour, so want to make sure we are good to go on these last few fraction concepts. Okay, so just a few things we wanted to work on here that we didn't have time to fit in before the last test, but also things that wanted to save till after I'd made sure we were good to go. Things like complex fractions. What is a complex fraction, Maddie? Okay, that's true. I was sorry. I was going more for like, but as far as functionally, when we see it, we should be thinking, oh, I need to, there we go, divide or multiply by the reciprocal, because a complex fraction is really just a division problem. As long as, Gavin, we have just one fraction
each
over the other fraction. There we go. So we need to make sure it's all 1 over all 1. And then, of course, we can go from there. We talked about rational equations, equations with fractions. And we still, Noah, simply well, I mean, you know, that's always a good default answer because it seems to come up so much. But when you have an equation with fractions, you should hate those fractions, shouldn't you, Noah?
Multiply.
Multiply everything by the LCD, right? But the difference was this latest round, because you're multiplying by a variable, every now and then it may come up that we get an answer that just doesn't check. We haven't seen too many of them, but every now and then they'll come up. Those answers that don't check, we call these extraneous roots. Good, something to check for. Then yesterday, we began looking at some word problems involving fractions and how to set those up. And a lot of times, those word problem equations turn into just one fraction equal to one fraction. Class, we would call that a proportion. And how do we solve a proportion, class? Cross multiply. So let's take a look at the homework. Numbers 25 through 29, 33, and 34. Thanks, sir. Good. And good. And good. All right, so I'm going to take a look at these together. Number 25, first of all, I noticed there's only one denominator, right? X plus 1. So here's a great opportunity to multiply everything by the LCD. Did anyone do that? You just multiplied everything by x plus 1. Okay, Noah, you did. So Noah, when you multiply by the x plus 1, you got 2x plus 2 when you distribute the 2, and then plus 1, because the x plus 1 cancels. And then the denominator, 3x plus 3, and then minus 5. To end up getting a 2x plus 3 over 3x negative 2, and boy, wasn't that easy, right? Those of you who did not, how many got the single fraction over single fraction? Got them both over x plus 1s, okay? So in the numerator, you kind of get the same thing, right? You put the x plus 1, and you still get 2x plus 2 plus 1. And down here, x plus 1, and you get 3x plus 3 minus 5. You end up having to multiply by the reciprocal. So we get a 2x plus 3 over x plus 1 times x plus 1 over 3x minus 2. Now, the one upside of doing this is that you'll visually see the canceling. And so when you get this answer, you'll be more prone to remember to say x can't be negative 1. The downside, knowing doing it this way is it's so easy to forget about the excluded value. How many had this answer doing it this way? Ooh, still only Maddie. How did we screw this up? Yes?
I forgot to add the 1 to the 2.
Okay. Okay. Did you remember the excluded value by any chance? And it's so hard. That's the only downside of the shortcut. And I'll be real frank with you, I forgot it too. Until I was doing this, I'm like, oh yeah, the excluded value. It's just hard to remember. So that's the only downside of doing that. But otherwise, it's a great method to use. As far as getting the actual answers, that pesky little half point on a test, maybe point on a quiz. Number 26, I would not do the multiply everything by the LCD method. I would set up my long fraction bar here, and then in the top, we have both an x and an x plus 3. So multiply by an x, and multiply negative 1. Are you looking at it there in your book, number 26? A negative 1 times the x plus 3 to get negative x, negative 3. Check your work. In the denominator, draw our line, we have an x plus 4. And in the numerator, of course, just multiply by the x to get 2x. In the numerator, multiply by negative 2, that x plus 4 to get negative 2x, negative 8. When we simplify here, then it's going to give us a 4x negative 3 over x plus 3, times, flip it, x plus 4 over just negative 8. So at this point, then, of course, we can cancel away the x's. And the negative that's down here is the only negative of any numerator or denominator. So it's going to have to come to the front of my answer to give me x plus 4 times 4x negative 3. I only flip-flop and put the simpler looking binomial first. It doesn't have to be flip-flopped. Do need to put the 8 before the x plus 3. And again, if you hadn't already moved the negative out front, now would be the time to do that. We did cancel away x's, so x cannot be 0. Also, the x plus 4 had moved up, so x cannot equal negative 4. And there would be our answer. How many have this for number 26? Questions? Considering you have a quiz over this kind of stuff in a little bit. All right, yes, sir.
So on the bottom, you wouldn't factor out the 2.
You don't need to yet because you combine before you factor, right? So as far as our steps, you simplify, then reduce. The reducing is the factor and cancel. The simplifying is combining like terms. So you always combine first. In this case, they cancel each other away. Then you would factor. Good question. Good. Any other questions? Technically, if you had factored Brecken, you'd have 2 times x, negative 4. And then when you try to combine, it would give you 2 times negative 4, which would still give you the negative 8 anyway. Right? Or you might have given that, yeah. So it still would have ended up canceling, just would have been a roundabout way of doing it. Any other questions on that? Did we find our mistakes? Were the mistakes these negatives? They were for you.
It was not that side, it was the one with the negative 2x instead combined.
Oh, you got a 4x.
Yeah.
Okay. Maddie?
I only had 1, 2x. I just had a 2, negative 2.
Okay, so where you had the 2 over x plus 4 minus the 2 over x, you multiply top and bottom by x, and that's where the 2x came from. And then here, when you multiply by the x positive 4, for whatever reason, you just didn't have the other 2x. All right, so just be careful then. Little mistakes. Little mistakes. All right, as we go to the next page, rational equations. Multiply everything class by the LCD. And in the first one, number 27, what is the LCD, Maddie? Good. The 6 is a winner, the y is a winner, the y plus 1 is a winner. It's very 2020 at 1-ish. Everybody's a winner. Everybody gets a trophy. And so our LCD here, I'm not going to write it every time. I'm just going to put 6y, y plus 1. So as we multiply by the LCD then, obviously we should see here the y is going to cancel with the y. But I'm still going to have the 6 and the y plus 1. Strategy. When you have two numbers, think of them as 1. Instead of 2 and 6 class, just think 12, right? 2 times the 6 would just be a 12. And distribute that to get a 12y positive 12. Here, of course, the y plus 1 cancels with this part, but I still have the 6y times the other y to get 6y squared. And then here, the 6's cancel, but I still have the y and the y plus 1. Well, again, think of this as a 5y and distribute to get 5y squared positive 5y. Checking your work, how many had this as your first step once the fractions were cleared? You had this. Okay, questions? Yes, sir.
I don't even know why, for some reason, I doubled the 12y. Into
Got a 24y. Okay.
I don't even know why that one was doubled.
All right. Others? Feedback? Just keeping it from dying on me. All right, any other questions, comments, feedback here? All right, from here, of course, we need to set one side to 0 because I've got the quadratic, right? And this is the big y squared, so we're going to send the little y squared over as a negative to get class 1y squared. Then I'm going to bring the 5y over as a negative 5y to get 7y, and I still, of course, have this 12 just sitting here, all equal to 0. That gives me y plus 3, y plus 4 for my factors. When you set them each to 0, y is equal to negative 3, y is equal to negative 4. Y can't be 0, y can't be negative 1. Neither of those is a 0 or a negative 1. You take time to check, and they do both end up checking out. But I don't think anybody got those answers, did we? Questions, last chance. Let's go to the next one, number 28. What's the LCD here, Brecken? Number 28. Good, just x times x plus 3. Of course, the 3 here is technically over 1. So again, as you multiply everything by the LCD, the x is going to cancel, leaving me with just the x plus 3 to get 40x plus 120. We see big numbers, we get terrified. All right, the x plus 3 cancels with the x plus 3 to just give me x. Of course, that's 40x. And here nothing cancels, so I get both the x and the x plus 3. Again, think of that as a 3x. As you distribute, you get 3x squared positive 9x. Conveniently, the 40x's cancel. Conveniently, then, the 120 could just slide over as a negative 120, and I could do something to make this look even easier. Anyone? Divide everything by 3 to get just x squared, just 3x, and just 40. That's going to backwards FOIL so much easier. X plus 8x negative 5 to get two answers of 5 and negative 8. X couldn't be 0 or negative 3. Neither of those is a 0 or a negative 3, and they happen to both check if you took the time to do so. How many got those answers on this one? All right, so Noah did better on this one. Not so much the first one, but got the second one. You also got the second question. Yes?
I got the wrong signs for each.
Oh, just the wrong signs. Okay, so
the opposite.
Presumably a factoring error then. Okay, because you were right as of here, perhaps?
That's right. No, it was positive 8 and negative 5.
Okay, can't read your own work.
No, I can.
So did you have x squared plus 3x minus 40 at some point?
Oh, but I see it. I think I factored the 3 times. Well, the 3x squared plus 9x didn't weigh that thing. Didn't probably weigh the 3.
Okay, all right. Questions from you two?
I combined 40x and 9x first.
To get 49, okay. Did you then send the 40 over as a negative 40 to still end up with the 9? It's not a problem to combine first. I always look for shortcuts because I'm lazy, but trying to indoctrinate you to be lazy also, but you don't have to be necessarily. Well, he's looking Maddie. Feedback.
I did feel like and so I decided that
So the factoring was just short. So you got the 3x squared plus 9x minus 120. Okay, it was just splitting all that up is just so hard if you don't get the common factor out of the way first. Okay, Bracken? Okay, so you had got to the same point correctly. It was just, man, that 120 is so hard to split up. Plus, if you're not careful, you'd be like, well, I can't put these two numbers together because then I don't have a common factor. Well, you do have a common factor. So, yeah, make sure we try to pull that out of the way first. So a good reminder to us. All right, we got the initial steps, which is so important. Number 29 was the last equation that we had here. The 1 over x plus 5 minus the 10 over x squared negative 25. And then the 3 over x negative 5. Without even doing the factoring, because again, I'm lazy, remember? I know this is x plus 5, x minus 5. I think you do too. And there's an x plus 5, and there's an x minus 5. So what is the LCD, class?
X plus 5, x minus 5.
X plus 5, x minus 5, right? I don't think we need to actually even do the factoring on this one. It's just that easy. So we see the x plus 5 cancels. That gives me x negative 5. We know this cancels all of it, so I just have... And here the x minus 5 is canceled to just give me times the 3.
3x positive 15.
There we go. So again, sometimes if it's super easy factoring, you save yourself a little work here. Let's combine here to get a
X negative 15.
equal to the 3x positive 15, not a quadratic. Don't have to set it to 0. Just get rid of the little x. 2x, thank you. We'll send the 15 over as a negative 15 to get careful.
Negative 30.
Good, they don't cancel, they give negative 30, so the x equals
Negative 50.
negative 15 when we divide. X couldn't be a negative 5, nor could it be a positive 5. Well, that's not either one of those, and again, presumably it checks, and it does. Questions on 29. Questions on 29. All right, any questions at all on these problems? All right, let's take a look at a couple of word problems that you did then, 33 and 34. Read 33 for us, if you would, please, Brecken.
If the same number is added to both the numerator and the denominator of 3 sevens, the result is 3 fifths. What is the number?
How did you set this problem up, Brecken?
3 plus x over 7 plus x equals 3 fifths.
All right, there it is. So we start with the fraction 3 sevenths. You said you added an x to both of them, and then it equals 3 fifths. Perfect. How many have the same thing? Same exact equation. All right. It's a special type of equation. It's a proportion, and we should cross multiply. What do we get when we cross multiply, Maddie?
15 plus 5x equals 25 plus 3x.
There we go. The product of the extremes will equal the product of the means. We'll pull a double switch here, Noah, to get
48x equals 28x plus 20.
Hmm?
Oh wait, no, that's
Let's just look over the board and not worry about what's on the paper. Let's pull a double switch. Let's pull the 3x over as a negative to get,
2x.
and then let's send the 15 over as a negative to get. What's 11 minus 5, Noah? 6. There we go. And of course, you know the ones are good. Okay, and then x is equal to 3. Let's see if this actually works, though. If we added a 3 to 3 sevenths, 3 to 3, 3 to 7, we would get what fraction, class?
6 over 11. 10.
6 tenths.
Yeah.
Is 6 tenths equal to 3 fifths? It checks. How many got 3? All right, let's take a look at number 34. Noah, for some redemption. You should read this for us.
The denominator of a fraction is 3 more than the numerator. If the numerator is multiplied by 5 and the denominator is multiplied by 4, the result is equal to 7 over 8. What is the fraction?
All right. We looked at a problem like this yesterday where it says, what is the fraction? Almost like there's one thing we're looking for. But a fraction consists, class, of 2 parts. What are the 2 parts of a fraction? Numerator and denominator. So when it says what's the fraction, it's really saying what are the numerator and denominator. So my 2 unknowns, class, are numerator and denominator. And which one, how many first of all recognized this, that there are 2 things we are looking for, the numerator and denominator. Okay? Now that also would have been helped by just reading the whole problem up until the last sentence where it keeps talking about numerator this and denominator that, right? Which of them should have been x, Noah?
The denominator. Or the numerator.
Okay, why the numerator?
Because that's what it comes back to.
That's what it comes back to in the comparison sentence. The denominator is 3 more than the numerator. Numerator is x, denominator.
Is x plus 3.
I think this is very similar to one that we worked in class yesterday. So literally, what is my fraction, class? X over x plus 3. That's my fraction. X over x plus 3. But I do something to my fraction. I mess around with it a little bit. What do I do to the fraction here, Gavin?
You multiply the numerator by 5 and the denominator by 4.
And when I multiply the numerator by 5 and the denominator by 4, suddenly my fraction of x over x plus 3 becomes equal to 7/8. The original fraction ain't equal to 7/8. But once you monkey with it, now it's equal to 7/8. How many have this equation? All right, only, okay, good, a couple of you did, all right. Questions from those who did not question. You,
I forgot the parentheses.
uh-oh. So you had 4x plus 3 instead of 4x plus 12, which is what we should have ended up with here in a moment. All right, questions? Speaking of which, let's go ahead and get that 4x plus 12 right here. Once again, class, we have a proportion, once again, we should cross multiply. When we cross multiply the extremes, class, 40x. When we multiply the means,
28x plus 28.
28x plus who?
20.
7 times 12?
Not 84.
We can move the 28x over the negative 28x to get 12x equals 84, and x, class, would have equaled 7. Maddie, you're the only one who had the right equation. Is this what you had? All right. So, Maddie, what's my fraction? Uh-oh. What's the numerator of my fraction, Maddie? And what's the denominator? So what's my fraction, Maddie? 7/10. Now, let's check, because that obviously doesn't equal 7/8, right? But it never said my fraction equaled 7/8. Did you catch that? My fraction didn't equal 7/8. It's not until I monkeyed with it, right? It's not until, Maddie, we multiplied the top by 5 to get 35, and not until I multiplied the denominator by to get 40. Now it would have equaled 7/8. But the fraction is 7/10. And that should have been our answer. Does that make sense, Maddie? So right at the end, kind of, you went with the monkeyed with the fraction, but that's not what we were looking for. We were looking for the actual original fraction. Does that make sense now? From the rest of you, we saw a couple of these yesterday. You now had a chance to practice with them. Even if you didn't get it right, hopefully having practiced it, now having seen it, it makes more sense. Any questions on these before we try another couple problems together? All right, let's go and try a word problem together now. I'm going to give you just a few moments to work on this at your seats. Take a few moments to work on this there at your seats. If you finish early, go back and do page 451, number 32. So work the word problem first. If you finish early, go back and do problem 32 there on page 451. How many had the denominator as x? And the numerator is 2x negative 9? So your fraction then literally is 2x minus 9 over x, correct? But then we do something. We add 1 to both terms of the fraction. So that this becomes x plus 1. And this, if you added 1, would become 2x minus 8. How many added the 1 correctly to both terms of the fraction? Questions on that? Once we've monkeyed with the equation, so to speak, it says it's going to become equal to 1/3. How many had the correct proportion then? All right, question? All right, so from here, Noah, we should cross multiply. Let's start with the extremes.
6x.
And then, of course, the means just.
X plus 1.
And then let's pull a double switch. Send the x over, send the 24 over. We get
5x equals 25.
so x just equals
5.
5. So, therefore, my 5 in the denominator, good.
And 1.
So my fraction is 1/5. Now, is this the same thing as a third class? But the problem never said my fraction would equal a third. It said it would equal a third if I did what? Added 1. What would this be if I added 1 to both terms, class? 2/6. Does 2/6 equal a third? Then it checks out. My fraction is indeed 1/5. How many had 1/5? All right. So Noah, it makes sense now? All right. Let's go ahead and take a look at page 451 then, number 32. Anyone? Anyone make some good headway already on this? Anyone make headway already? All right, go ahead and copy it down then if you have not already. Go and copy down number 32 on your paper. But don't copy it as written, right? We don't need to do that. Y minus 2 over, how should I copy this first denominator, class? And how should I copy my second numerator? Someone else, or second denominator? Someone else?
Y negative 2, y positive 2.
Good. And row 1, how should I copy my third denominator?
3 times y plus 2.
All right, so way to go, guys. Maddie's turn then. Maddie, what's the LCD?
2 times y negative 2.
That's a big, long denominator, isn't it? This is a great example of why I don't like to write it every single time necessarily. This is a great one. So obviously we know the y plus 2, y minus 3 is going to cancel. It has to, or else I didn't do my LCD right. What's still left over after I cancel the y plus 2 and the y negative 3, class?
2y negative
2 and y negative 2. Make sense? At your seats, figure out what that is. Did you get 2y squared, negative 8y, positive 8? Start with the binomials. Distribution's easy. Save it for last. Get the binomials while they're still really basic. Y squared minus 4y plus 4, then distribute the 2. All right, come to the next one. Obviously, the y minus 2y plus 2 cancels. What's still going to be left, class?
2y negative
All times a 1. So really, it's still just 2 times y negative 3, or, class,
2y negative 6.
on the last one. Obviously, the 2 and the y plus 2 are going to cancel. What's still going to be left?
y negative 3, y negative 2.
All right, so let's multiply those. Again, it's faster if you FOIL first, then distribute the 3. Do so. Did you get it? 3y squared minus 15y plus 18. Finish the problem at your seats. Is this what you got? Excellent. Not what you got. Check your combining, maybe check the setting equal to 0 step, see if you can find your mistake. Gavin? Did you figure out where it happened, Maddie? Careful, yes, the negative 8 comes over as a positive 8, gives you the negative 5. So I don't often show this step, but if you wanted, I mean, it doesn't hurt to show that step right there, right? Cross them out here, write them as inverses there, changed signs, might help you there, all right? Gavin, Noah? Questions, comments? Any questions before we take a quiz? Going once on questions. Going twice on questions. Going on questions. All right, everything on your desk except for a sheet of paper and a pencil. One sheet of paper and a pencil, everything else away. First and last name at the top of your paper, along with today's date, which is 2/5/21. 2/5/21, today's date. 2/5/21, today's date. you're watching on YouTube, after I start them on the quiz, I'll be putting the homework assignment on the board. Leave it up for just a few seconds and end the video. First class name at the top of your paper along with today's date, 2/5/21, and this is quiz 21. Let's go and take a look at the quiz together very quickly. Numbers 1, 2, and 3. You are simplifying those fractions, those complex fractions, I should say. Numbers 4 through 8, solving those rational equations. Those first couple should be really quick. Don't overthink them. And then number 9, you've got a word problem. Of course, set up the equation first and solve. And you may begin.